Hello everyone, I am Adya from Sri Venkateshwara College of Engineering from Department of CSE. Today I am going to give you all a presentation on Linux kernel development. Overview. Introduction. What is the Linux kernel? History of the Linux kernel development. Structure of the Linux kernel. Contributing to the Linux kernel. Challenges in Linux kernel development. Tools for Linux kernel development. Linux kernel security. Future of Linux kernel development. Conclusion. Introduction. Welcome to the exciting world of Linux kernel development. This is where the magic happens, where code is written and optimized for maximum performance. It's a world of innovation, collaboration, and cutting edge technology. But why is it so important? Simply, but the Linux kernel is the backbone of many operating systems used today. From smartphones to supercomputers, without it, our digital lives would look very different. By contributing to Linux kernel development, you have the opportunity to shape the future of technology and make a real impact on the world. What is the Linux kernel? The Linux kernel is the core component of the Linux operating system. It is responsible for managing system resources such as memory and CPU time and providing a platform for other software to run on top of. Unlike proprietary operating systems such as Windows or Mac OS, the Linux kernel is open source, meaning that anyone can view, modify, and distribute its source code. One of the key differences between the Linux kernel and other operating systems is its modularity. The Linux kernel is made up of many small interchangeable components, each with a specific function. This allows developers to easily customize and optimize the kernel for different use cases such as embedded devices or high performance servers. The history of Linux kernel development. Linux kernel development began in 1991 when Linus Torvalds, a Finnish computer science student, released the first version of the kernel as open source software. Since then, the kernel has undergone numerous updates and improvements with contributions from thousands of developers around the world. Some key milestones in Linux kernel development include the addition of support for multiprocessing in 1996, the introduction of the O1 scheduler in 2001, and the integration of the Android operating system into the kernel in 2009. Notable contributors to the project include Andrew Morton, who served as the kernel maintainer from 2003 to 2008, and Greg Crowe Hartman, who has been a major contributor since 2001 and currently maintains the stable branch of the kernel. Structure of the Linux kernel. The Linux kernel is made up of several components, each with its own specific role. At the core of the kernel is the scheduler, which manages the allocation of system resources such as CPU time and memory to different processes. The memory management subsystem is responsible for managing the allocation and deallocation of memory, while the virtual file system provides a unified interface for accessing different types of file systems. Other key components include the network stack, which handles the networking protocols such as TCP or IP, and the device driver framework, which allows the kernel to communicate with hardware devices. These components work together in a highly integrated manner to provide a robust and reliable operating system. Contributing to the Linux kernel. There are many ways to contribute to the Linux kernel development community. You can start by reporting bugs and issues, which helps developers identify and fix problems. Another way is to participate in code review where you can provide feedback on proposed changes and help ensure the quality of the code. If you have programming skills, you can also contribute by writing new code or improving existing code. By contributing to the Linux kernel development community is not just about coding. There are many other ways to get involved such as documentation, translation, and community outreach. By contributing in these areas, you can help make the Linux kernel development community more accessible and welcoming for everyone. Challenges in Linux kernel development. Developing for the Linux kernel can be a challenging task as developers often face compatibility issues and conflicting goals. With so many different contributors working on the project, it can be difficult to ensure that everyone is on the same page and that changes are made in a way that does not break existing code. However, these challenges are not unique to Linux kernel development, and with the right mindset and tools, they can be overcome. By embracing collaboration and open communication, developers can work together to find solutions that benefit the entire community. Tools for Linux kernel development. Git is a powerful version control system that allows developers to track changes to their code over time. It makes it easy to collaborate with others and keep track of different versions of the code. With Git, developers can easily revert changes or merge code from different branches. Coccinelle is a tool for finding and fixing branches in the Linux kernel source code. It uses a powerful pattern matching language to identify potential issues and suggest fixes. This can save developers a lot of time and effort when trying to debug complex problems. Linux kernel safety. Developing the Linux kernel requires a deep understanding of security considerations. Vulnerabilities and attack vectors can compromise the integrity, confidentiality, and availability of the system. Therefore, developers must follow secure coding practices such as input validation and memory safety. To prevent common vulnerabilities like buffer overflows and integer overflows, moreover, the Linux kernel must be designed with defense in depth principles in mind. This means that security features such as access control and cryptography should be layered to provide multiple lines of defense against attacks. For example, the kernel security module framework allows for different security modules to be stacked on top of each other to enforce various security policies. Future of Linux kernel development. As we look to the future of Linux kernel development, it's clear that the possibilities are endless. With advancements in technology and a growing community of developers, we can expect to see even more innovation and progress in the years to come. One area where we may see significant growth is in the field of cybersecurity. As more devices become connected to the internet, the need of secure and reliable software will only continue to grow. The Linux kernel development community is well positioned to lead the way in this area with a strong focus on security and a commitment to the open source development. Conclusion. In conclusion, Linux kernel development is a fascinating and constantly evolving field that has played a critical role in the development of modern technology. Through its rich history, we have seen how this community driven effort has grown from humble beginnings to become one of the most important software projects in the world. As we look to the future, it is clear that there are many exciting developments on the horizon for Linux kernel development. Whether it's new technologies, new contributors, or new challenges, there is always something new to learn and explore. So, I encourage you all to continue your journey into the world of Linux kernel development and to never stop exploring the possibilities of this amazing field.
Thank you so much for watching. If you like the presentation, please do like, share and subscribe.